backwards here. All right, so for 7 and 8, it asks you if there was enough information. I sort of looked for my congruencies here. And notice it was the red triangle on the left side and then the blue one on the right. And I could have proved them congruent. I had 2 angles already marked, and I just had to show the reflexive side. Now, what I recommend you do when sometimes these things are overlapping like this, pull them apart. So if you pull them apart, so like say this is the blue one, the left side, the right side. So this is D, CB, and over here is A, BC. So see the BCs are reflexive, they're congruent to each other. These guys right here have the right angles, and then these guys got the tips up here that are congruent. So this would have been angle, angle, side.
You could have used angle, angle, side.
I'm sorry?
You could have used angle, angle, side.
Angle, angle, side, that's what you would have used.
Like why don't you use the base angles here or whatever?
Because we didn't have an acute triangle here. I mean, an isosceles triangle here.
So on the test, you could give us some examples that aren't even isosceles triangles.
Correct. So it's anything from 4-4 to 4-8. They may be isosceles, they may not. All right, number 6, there's not enough, or number 8, sorry, there's not enough information. All we know are about congruent angles. We do have parallel lines, we can find some corresponding, but there is no AAA postulate. Okay, because remember, you can have similar triangles with congruent angles, but the side lengths are going to be different. Okay, so they'll be similar but not congruent. So not enough information here. Good? All right, number 9. You're filling in the proof.
Can you explain the whole?
How the proof goes? All right, so my recommendation to you guys is the first thing you should do is put the congruency marks in your triangle so you can sort of get a better visual. So FG is congruent to FJ, and HG is congruent to IJ. So right away, I can sort of see here, I'm probably referring to the 2 triangles on the sides here. These are the ones that I'm going to try to prove congruent. So I already have 2 sides. I'm going to see if I can pull in another side here, or maybe another angle. So I'm going to go ahead and realize that I have an isosceles triangle here, if I refer to the whole big one. Now, when they're overlapping like this, you're going to have to realize that there's more than one triangle here. There's actually 4 different triangles here, or even more than that. Well, you could have done the 3 little individual ones, the big pink one, and that's what I'm going to talk about right now. And you could have even overlapped and even saw like this one together and this one together. There's more than one triangle here. But the one that I need to refer to are the 2 blue ones and then the big pink one. Notice the congruency marks on the side here, making this big pink triangle an isosceles triangle, which tells me that these base angles are now congruent. And now I have enough information in the 2 side triangles to prove them by side angle side. Because I've actually got a congruent angle here, and I've got a side, an angle, and a side. A side, an angle, and a side. So once I threw in the base angles theorem, because the 2 sides were congruent, then the base angles are congruent. Then the given again, and then I can show by side angle side. And then now, this one piece that does, or this piece that doesn't have a congruency mark, the HF congruent to IF by CPCTC. Because it's part of the triangle I just proved congruent, but it didn't have a congruency mark.
So the base angles theorem, it's really just going to be a reason that's like inside the proof, not the last step of the proof?
Correct. Now, in some cases, it's going to be the last side, or last step. It can be anywhere.
So number 2, when I was doing, I was looking at the small triangles and I wasn't getting why it was based.
Right, so you're going to have to tie in other triangles that are in the picture. And this is how it's going to start getting more complicated, especially with the parallelograms and what we're going to be covering when we get to quadrilaterals. All right, everybody good on this proof? Let's go to the next. So this is the homework from lesson 4-8. For number 1, the first thing I looked at was there was 2 congruency marks here, indicating that these sides were congruent. So I could apply my base angles theorem, and I could state that this angle was congruent to this angle. And I set up my equation as 3x minus 11 equals 2x plus 11. Solve for x. Then what I did was I ended up finding out how much the angle measure was by plugging 11 into one of them. It didn't matter which. I ended up doing the 2x plus 11. I found it to be faster. And I found out that the angle measure was 55. So then that told me that both angles here are 55. I can add them and get 110. I could have minus that from 180 and found out that this missing angle here needed to be 70. Now I ended up actually setting up the entire equation, 55 plus 55 plus 2y equals 180. And then add the 55, subtract it, and then divide. And find out y equals 35. Everybody good on number 1? Number 2, I had to realize that I had a right triangle here. And we learned the corollary that stated that if you have a right triangle, that the two acute angles are complements. So I knew that these 2 base angles that were congruent had to equal 90 degrees. So if I divided 90 by 2, I knew that both base angles had to be 45. So then I set up 2 equations, 3x equals 45, and then y plus 7 equals 45, and then solve. Everybody good on 2? Let's go to 3. All right, so for number 3, here again, I've got 2 congruent sides. So that told me that the base angles were congruent. So if this angle here is x minus 2, then this one over here is x minus 2. I'm going to apply my triangle sum theorem, and I know that all 3 angles need to equal 180. So I have one base angle here, the other base angle, and then I have the 4x plus 10. And then I'll combine my like terms, and then begin my inverse operations. And I find out x equals 29. Then I could, yes?
So the x minus 2 is the same for both sides?
Correct, because see the 2 congruency marks here? This is indicating that the sides are congruent. So by my base angles theorem, I know that the base angles are also congruent. So then now I'm going to take what x equals and I'm going to plug it in to the x minus 2 and find the interior angle. They're a linear pair.
So you don't have to divide by 2? Like,
no, because the way I set it up equal to 180. All right, so then once I found the interior angle, it's a linear pair with the 3y. So then I just do 3y equals the 153. And then divide by 3 and I get 51. Everybody good on 3? All right, let's go to 4. Okay, so here I actually had 2 isosceles triangles. I went ahead and, let's see, marked my congruencies. So notice that right here is my first isosceles triangle. The congruency marks here on the sides tell me that my base angles are congruent. So that's how I knew I could set 3x plus 10 equal to 5x minus 10. And that's going to give me my value of x. Then once I found that 10, I actually plugged it in to the 3x plus 10. And I found out the angle measures to be 40. This way I could find the value of the vertex angle. So if I did 40 plus 40, that gave me 80. And then that led me to know that my vertex angle here was 100. So then once I found that to be 100, I could find the linear pair, the other part of it, and find out that it was 80. So right here, this angle's 80. And then again, I've got another isosceles triangle. So I know that 4y equals 80 because the base angles are congruent, and that's where I solve down here to get y. Yes. So on this one, it gave you the vertex angle, which was 142. And then you could have just done 180 minus 142 and found out it was 38 degrees, which had to be shared by the two base angles. So you had to divide by 2, and it was 19. Okay, the next one.
So for these, we do divide by 2.
Yeah, it all depends. Each problem is different depending on how you're finding it.
Can you explain
Number 5? Okay, so again with number 5, I have two different isosceles triangles here. I have the top one, which I'm going to use to find x. Notice the two congruent sides here tell me that the two base angles are congruent. So then to solve for this, I realized that 2x plus 11 is this angle. So because it's the same as this one, I put 2x plus 11 twice for the two base angles. Then the vertex angle up here was x minus 2. And I know that all three angles need to equal 180. So I set up my equation as the 2x plus 11 plus 2x plus 11 plus x minus 2 equals 180. And then from there, combine your like terms and solve and get x equals 32. Then to find the y, it was the bottom isosceles triangle. They gave you the vertex angle. So all you had to do was subtract that from 180 and then divide by 2. On this one, as soon as I realized I had some vertical angles here, I knew that these base angles were congruent. Really, I didn't need to go as involved as I did. I probably could have just done 2x minus 25 equals x plus 5. And then I find x equals 30. And then I plugged it back in. And then I subtracted that from 180 and set up my equation and got y equals 13. The vertex angle was congruent. I really didn't need to know it. Because it was the vertex angle was the same for both, I knew my base angles were congruent on both triangles. They're not congruent triangles, but they're similar triangles. So I knew that the pink one and the blue one had to be congruent.
But why is that? If vertex angles congruent, why does that mean
Okay, so think of it this way. Let's say you have a picture like this. And let's say the vertex angle is 40. And actually, let me draw a picture where they're touching. Like I'll make the bow. That's what somebody called this figure. So let's say we have our two triangles here. And these are congruent. So let's say, and they have the congruency marks here. And let's say this angle right here is 40 degrees. So because it's vertical, I know this one's 40. How do you find the two base angles if you know that the two sides are congruent, you know the vertex angle? And then? And then divide by 2. So this is the logic I was using, that if I have a pair of vertical angles, that to find the two base angles, I'm going to subtract that vertical angle from 180 and then divide by 2. So I'm going to get the same numbers for both of these sets of base angles. So this way, I could have just done x plus 5 equals the other base angle, which was 2x minus 25. And then once I find that, minus 5, actually let me move, minus 5. And then if I move the 2x over, I get negative 1x equals negative 30. Divide by negative 1, x equals 30. So you would just set them equal to each other because you knew they were congruent. Then I was looking for an exterior angle, so I had to subtract from 180. So I actually plugged the 30 into this one, and I found out that the base angle was 35. So then when I did 180 minus 35, that gave me 145 to set this equal to it. And that's what I did here. And got y equals 13.
And what is the x equal?
The x was the 30. Everybody good on 1 through 6?
Wait, where'd you put in the y at?
I didn't plug in y. I solved for y. I found that what that whole exterior angle should equal by plugging in x and get that the base angle was 35. And then
Find y before you find x though? Or no?
in this case, no. No, we would have had to find x first. Now, in some of the triangles, you may be able to find y first. You're going to have to, evaluate each problem and figure out what needs to be done first. And it'll be different. Everybody good on 1 through 6? Yes.
So you said that the x plus 5 plus what equals 135?
All right, so I found out x to be 30, right? And then when I plugged it in here for 30, I found out that these two base angles were 35 degrees. But I was looking for the exterior angle for y, so I had to do 180 minus 35, and I got 145. And then that's what I set 9y plus 28 equal to, because it was the exterior angle. And that's the work I did right here. Everybody good so far? All right, let's go to 7. I think it's on the next one. This is what we already covered. Page. Next page was number 10. So another proof. Okay, so again, put in the congruency marks. So I have angle 1 congruent to angle 2. And then I have side AC congruent to BD. Let me fill that. So this is a congruent angle, this is a congruent angle, and then I have a side. Now, what other thing you think we can tie into here to get that these two triangles here are congruent? I've got an angle and a side. So if I show the vertical angles, that's the obvious, are congruent, now I have an angle side, congruence. And then from there, once you prove them congruent, now you can go back and say that AE, this little piece here, is congruent to BE by CPCTC, because I've already proven the triangle is congruent. Now, it didn't ask for that. It actually asked for 3 and 4, but now that I've proven that these two sides are congruent, now I have another isosceles triangle with these base angles 3 and 4 congruent by the base angles theorem. So more than likely on these, there's going to be more than one triangle in the picture, and you're going to have to, tie in other triangles. Yes?
So CPCTC can refer to angles and segments, right?
And segments. So basically, back when I did these two pink ones congruent, not only could have I said the blue one that I put the tick marks on, I could have also said angle C was congruent to angle D by CPCTC. And I could have also said CE was congruent to DE by CPCTC. So once you put in a triangle congruency shortcut, then you can go back and say all the other pieces are congruent. And that's what CPCTC says. Yes?
Can you put practice A up for this?
I believe it's up there with the answers.
It's already up.
It's already up. I put all the practice A's up. They're in the modules. They're not going to show up on your assignment list.
Yeah, you have to go through the modules.
Yeah. And the answers are with them.
Okay.
All right. So for 11 through 16, again, this is the same situation. We've got an isosceles triangle here. I've got another one right here. I've got another one up here. So there's more than one isosceles triangle in this one picture. Now, when they give you the sides congruent and you're proving angles congruent, that's the base angles theorem. But when they give you the angles congruent and you're trying to show the sides, That's the converse of the base angles theorem. Of number 17 on your test, where I'm going to give you an isosceles triangle, and I'm going to tell you like the two side lengths are congruent, and I'm going to give you the vertex angle. So this is where you would subtract from 180 and then divide by 2. Yes.
So 17 could be on the test,
Yes.
but 18 through 19 no.
Correct. Yes. So you could have a question like 17 on the test, but nothing as complex as 18 or 19.